Start.
Good morning, students. So today we are going to learn about the last topic of our chapter motion, and that is uniform circular motion. Now the question is, what is uniform circular motion? So let's have an understanding about that. In the first case, see, the person is running on a rectangular path. So can we say that the person is having a uniform motion? Can we say that? Think about it. No. Why? Because while running onto this rectangular path, the person is continuously changing in direction from here, here and here. And as he is changing his directions, we cannot say it is a uniform motion. Because we have studied that if it is a uniform motion, the path should be a very straight line. That's right. So definitely the velocity of the person is not uniform because the person keeps changing his direction at every corner of the rectangle. So it was about rectangle. Can I say something about this one? Will the velocity remain non-uniform too if we increase the number of sides? See, here we have increased the number of sides. Will the velocity remain uniform? Will the velocity remain uniform? No, definitely not, because again we are changing the direction at each corner of this shape. So can we have a round shape? What about the round shape? Will the velocity remain uniform even if the person running with a uniform speed along the boundary? See, this is a boundary line. The person is running with a uniform speed. The person is running with the uniform speed. So can we say that the velocity is uniform? No, again no. So here the speed will be uniform but the velocity will not remain uniform because at each point of the circle the person is continuously changing the direction. Here it is in this direction, in this direction, this direction. So every point of the circle the person is changing its direction. So definitely it is not a uniform velocity, but it is a uniform speed. And uniform speed on which path? Circular path. So we can say that it is a uniform circular motion. Is that clear, students? Uniform circular motion. The velocity is not uniform. The speed is uniform, and we are running on which kind of path? Circular path. That's why this motion is said to be a uniform circular motion. Now, how to calculate the speed? The question is, if the person is having a uniform circular motion, if the speed is uniform, and how to define the speed, how to calculate the speed. So for that we have one formula, one basic formula, even you all know about that formula. See, this one is a circular path and we have studied about the speed. What is speed? Speed is equals to distance upon time. Speed is equals to the distance upon time. And what distance we are covering here? Can anybody answer the question? What distance we are covering here? Very good. Here we are covering a distance of a circle. It means we are covering the distance of a circumference of the circle. And what is the circumference of the circle? It is 2 pi r. And what is the time taken? Suppose the time taken is t. So this is the equation for the uniform circular motion. If they ask you that any person is going on a circular motion and radius of the path is 2 meters, then we can easily find out the speed of that person. Are you getting it, students? Okay. So let's have a look at here on the equation. Yes. And again, uniform circular motion is an example of accelerated motion. Why? Because each and every time we are changing the direction. And whenever we are changing the direction, we must have to slow down our speed. We must have to change our speed, and that's why increase or decrease is known as a accelerated motion. So here also the uniform circular motion is a kind of accelerated motion, and here is the equation? Yes. V is equals to 2 pi r upon t. The speed V is equals to 2 pi r upon t. Why 2 pi r? Because we are covering the path which is circular. And circular path, it means the circumference of a circle, and time given is t. So we can definitely say that speed is equal to distance upon time. Here distance is 2 pi r and time taken is t. Therefore the speed is 2 pi r upon t. Now where we can find this kinds of motion in day-to-day life? So here are some examples. Suppose the motion of a tire of car is a circular motion. The motion of a blades of fan is a circular motion. So this is the basic topic, uniform circular motion. Are you getting it? Okay. Thank you.